Today we are going to tackle a monumental challenge that critical for our planet's future, the journey towards green steel. Steel is absolutely indispensable for modern life, forming the backbone of our infrastructure, vehicle, and countless products. The iron and steel industry contribute a staggering 3 gigaton of CO2 per year, accounting for an astonishing 9% of global energy related emission. At the very core of this challenge is the fact that 70% of global steel is produced using the traditional blast furnace or BF process. This is not just a number, it's a massive hurdle in our journey towards a sustainable future, demanding innovative and immediate solution. Now let's talk about the blast furnace itself, often labeled as a dinosaur technology in decarbonization discussion. The scientific reality tells a different story. Experts widely agree that the blast furnace is in fact the most economic and efficient route of iron production and the most efficient way to produce iron making globally. This is a traditional route generates a significant 2.3 to 2.5 ton of CO2 per ton of crude steel when considering both direct and indirect emission. It's responsible for producing around 1.2 billion tons of iron per year. The hard logic is clear. We cannot blow down all the blast furnaces today because the renewable energy is not there at the scale to replace them. This makes steel a truly hard to abate sector. However, here is a critical window of opportunity. Over 70% of existing blast furnaces will require reinvestment by 2030. This presents a unique chance to integrate new technologies for decarbonization rather than simply replacing them. So, if we cannot simply get rid of blast furnaces, what's our immediate effective solution to decarbonize them? The answer is carbon capture, utilization, and storage or CCUS. This is not some experimental concept, it's a mature and proven technology ready for deployment right now. Experts state that CCS remain one of the most effective and less invasive methods to achieve deep emission cuts. Think of it as a vital bridge technology that allows us to dramatically reduce emissions now while the broader energy transition unfolds. One of its most important and significant advantages is that CCUS can be retrofitted onto existing assets. This means steelmakers can maintain their current production infrastructure, avoiding massive disruption and allowing for a much faster transition to greener operations. Let's delve a little deeper into the proven nature of this technology. The companies like Mitsubishi Heavy Industry or MHI are a world leader in post-combustion capture, specifically amine scrubbing. They boast 17 large-scale operational references globally, demonstrating the technology's reliability and scalability. In fact, MHI's technology is responsible for capturing 70% of CO2 globally. To give you a sense of the impressive scale, the largest operating plant, Petronova, captures close to 5,000 tons of CO2 each day. These are not just pilot projects, these are large scale industrial operations proving that carbon capture works effectively and efficiently. It's truly a mature proven technology that can make an immediate and significant impact on steel's carbon footprint. Despite its maturity and proven track record, we face significant hurdle to widespread adoption. The International Energy Agency or IEA projects by 2060 CCS will need to be installed on approximately 21% of global crude steel production capacity. This translates to capturing a colossal 506 million tons of CO2 annually. However, the reality is that we are currently falling short. The primary stalling factor is insufficient financial incentives or regulatory framework hasn't engaged large-scale projects in the steel sector. Currently, only Emirat Steel Abu Dhabi processes has achieved large-scale CCUS capturing above zero point 0.5 million tons per year. A core barrier remains the lack of proven storage site and clear regulatory framework for CO2 storage utilization. And of course, the cost is quite high, emphasizing the urgent need for robust regulation and government support to make these projects viable that scale up efficiently. Now, here is where things get really exciting and innovative. Beyond just disposal, captured carbon can be turned into economic gold. We are shifting our paradigm to see CO2 not merely as a waste product, but as a vulnerable feedstock for new industry, creating a compelling CO2 ecosystem. These are several utilization pathways already emerging. For instance, in chemical and fuel, methyl partnership with a Lanzatec is successfully converting blast furnace gases directly into ethanol, which can then be used for various chemicals and textiles. CO2 is also already utilized at scale to produce urea for fertilizers, and there is a huge demand on methanol, on green methanol for energy storage and e-fuel, particularly for maritime applications. We also have a ethanol oil recovery or EOR as a long-standing method for carbon dioxide utilization. The true game changer, however, is biogenic CO2 capture or BECCS. By capturing CO2 from biomass gasification, like in Sweden Ferrosilva project, we can create a carbon sink actively removing CO2 from the atmosphere. This transforms a liability into an asset and create a clear financial drivers for decarbonization. To truly accelerate deployment and overcome these hurdles, we need a multi-front battle plan. This involves several strategic pillars. First, focus R&D. We must intensify research into the most cost-effective and energy-efficient capture technique. Pilot projects are crucial for capex optimization and de-risking new technologies. Second, a robust regulatory framework. Establishing a stable condition and a proper CO2 pricing system is essential to enable final investment decisions or FIDs. These includes developing clear national and regional roadmaps. Third is cross-sector collaboration, forging a strong partnership between industry, academia and governments and financial partners will allow us to share knowledge and resources more effectively. And finally, public awareness and education, a crucial step to address anxiety and build trust in CCUS as a viable and necessary solution. Industry leaders like MHI are already committed, aiming to be carbon neutral by 2040 and offering only enabling technologies to carbon neutrality. The path forward is clear. Let's the options that are available now and think what can we do with the capture